Okay, first today I want to give you some two example of problems. So the first problem, as we know, that for example, if there are three charges, okay, Q1, Q2, and Q3, okay. Q1 equals to Q3 equals to 5 micro. This is mu, means micro. So it means that micro column, it means micro column, it means 10 to the minus 6 column. Okay. So the distance between Q1 and Q2 is A, okay, and Q2 and Q3 is A, okay. So the distance between this Q1 and Q3 is A square root 2. Okay, so if we want to know about F23, F23 means that okay, the convention is different, yeah, from last, sorry, I should, just a moment. To one force act on Q2 caused by Q1. Okay, but this is just a moment. Sorry, F23. These books have different convention. Yeah. Last week I said that F23 mean that the force act on Q2 caused by Q3, but this is F23. It means that the force act on Q3 caused by Q2. Okay. Okay. So the magnitude of F23 is this one. Okay. So the magnitude of Q2 is the minus, I think, yeah, minus 2 microcoulombs. Okay, and the A here is 0.1 meter. So the magnitude of F23, so we get, if you insert the formula, the number, then we get approximately that it leads that this should be 9 Newton force on Q3. So this is equal to okay, this is equal to F equal to F32, okay, the magnitude. Okay. Okay, let us continue. So, and then also we could also calculate the magnitude of the force F13. So F13 means that act on Q3 caused by Q1. Okay. So if we insert the value K, Q1, Q3, and A, we get this F13, the magnitude is 11 Newton. Is there any question until this step? I think it's trivial, okay? Any question, okay? No question, okay. So, if you see this triangle, okay? This, for example, theta here. Okay, sine theta is equal to y over r, okay? Y is A, and r, the hypotenusa, is A square root 2, so it should be, okay. So this theta, it means that is 45 degrees, okay? So that's why we conclude that F13 with respect to the x-axis, yeah, it makes an angle of 45 degrees. Okay, so this is so this is theta. Okay, this is, yeah, because it's 45, the same. Okay, any question? Okay, any question? No. Okay, let us continue. So it means that if we have this angle is 45 degrees, okay, it means that the F13 here, we have the component, the x component, the magnitude is F13 cos 45 degrees. Okay, so it should be around 7.9 Newton. And also for y component of F13 equals, we can replace this for y component is F13 sine 45 degrees. Okay, it should be 7.9 Newton. Okay. So because the angle is 45 degrees, we have F1 3x and F2 3x. I should this one. So we have F13x is equal to F13 cos 45 degrees and F13y, the y component of F13 is sine 45 degrees. So this is equal, okay? So it means that the resultant F3, before that, F23 is, we have this. Yeah, you see that the direction of F23 is to the left, okay? So it means that if we talk about the factor, its y component of F23 is minus 9.0 Newton. Okay, so F23y. Okay, there is no y component on F23, so it means simply 0 Newton. Okay. Okay. Is there any question about this? Any question? Okay. So let us proceed. Yeah. So we get that the x component of this F3, the resultant of F1 3x and F2 3x is equal minus 1.1 Newton. And also the y components of F3, the resultant, still 7.9 Newton. Okay. So the direction of this y component is to the up, up the up, positive, okay. And okay, this x component of the F3, the resultant, is minus, so it should be direction should be to the left. Okay, so if we rewrite this result, okay, in the context of complete factor, so we get that this is so this is the F3x and this is F3y. Okay. Is there any question regarding this problem? I will talk about this in Indonesia later, before maybe 15 or 20 minutes before the lectures end. Any question? Is it clear? Okay, if there is no question, I assume that all of you will understand what I'm talking about. Okay. Okay. The second example, we have 3 charges, okay? But these 3 charges lie on x axis. Just a moment. Okay. So 3 charges lie along the x-axis as shown in figure below. Okay. Q1 positive, the x is 2 meters, and then the positive charge Q2 is at the origin, okay, and the resultant force acting on Q3 is 0, okay. What is the coordinate of Q3? Where we should put Q3 such that there is no force act on it. Okay, it means that the resultant, if at the point where this Q3 lie, okay, is 0. Okay, so as you see from this picture here, okay, this F23 and this F13, okay, they have the opposite direction. Okay, so it should be there is a point. This is the indication. There is a point where the force is 0. Okay, so it should be the magnitude of F13 and the magnitude of F23 equals. Okay, so let us assume that the distance between Q2 and Q3 is x, okay, because the distance between Q2 and Q1 is 2 meters. Okay, so it should be the distance between Q3 and Q1 is 2 minus x. Okay, so we have this formula here. So you see that from this one, well, you could solve the quadratic equation, okay, and we find that it has 2 roots, okay. The first root is positive, but there is also the second root, okay, this minus 3.44, okay. So let us see, is it which one the solution is physical, is physical, okay. So if you take this one here, okay, we have this one and this one, okay, as shown in this figure, okay, F13. What about this one? If we put this minus here, it should be Q2, it should be this one, okay, F23, and this also this one, okay, F13. Yeah. Is it possible? In this case, no, because F23 and F13 have the same direction, yeah? The same direction. So it should be the resultant of these 2 forces cannot be 0. Okay. What about here? Oh, here is no. So it should be only positive, negative and positive. So the first solution here is the physical one. Okay, so this is the answer. So X should be 0.775. Okay, is there any question regarding this problem? Any question?
Sir. Hello, sir.
Yes.
I think there is someone in the waiting room.
Why there is someone in waiting room?
He got some connection problem and he told me that.
Okay. Okay. So they should inform our WA group and the reason why.
Okay, sir.
I think their business is not your business. Ya, maksudnya Anda tidak perlu ngurusin mereka, biar mereka yang membuktikan bahwa memang mereka tadi sudah masuk cuma terlempar gitu. Anda harus ada buktinya. Ya, berupa foto terkait dengan kuliah ini juga bisa. Oke. Ada pertanyaan nggak terkait ini? Ya. Ada pertanyaan nggak terkait ini? Kalau yang ini, any question? Okay, is it clear or? Okay, it's clear ya. Okay, we have discussed. Yeah, okay, this later. Oke, bagi yang mau ke toilet silahkan. Oke, this is this is yesterday, yeah. Sorry, last week I think on Tuesday. Okay. Column slow. I think this is already here. Just a moment. Sorry. Okay, let us discuss about electric field. Okay, next time you have to photo ya, screenshot about today's lecture. If you have a problem with connection, something like that. Jadi Anda harus punya bukti, ya tadi berupa foto atau apa terkait dengan kuliah. Jadi kalau misalkan nanti Anda pertama kali masuk, itu bisa Anda langsung foto. Ya, jadi untuk ke depan saya minta bukti memang kalau Anda apa namanya terlempar keluar gitu ya. Jadi Anda kan udah hadir. Okay, let us discuss about electric field. So last week, yeah, and also just now, we have discussed about force. Yeah, the Coulomb's law is related to electric force, yeah, between two charges. Okay, the other one is called source charge, and the other called test charge. Okay, so this source charge can be viewed as the source. Why we call it source charge? Because it can be viewed as the source of electric field. So this electric field is defined as A vector P. Yeah. So we consider if you take this, for example, this origin, the source charge lies at the origin, okay? And when we consider a point called P with distance R, yeah, and this R factor is the position factor, okay? Position factor. So if the electric field, in this case, at point P is defined as AP equals F over Q, okay? And Q, little q, yeah? This capital Q, we call it source, okay? This Q is a test charge, okay? Sorry, the test charge should be this one. Okay, this is F here. This is F. Okay, the force. So if we take the limit, yeah, this limit, for example, we take this one, sorry. If we take here limit, so the Q goes to 0, okay, we get this electric field formula. So this K, capital Q over 2 squared and times R hat, yeah, is the electric field of the source charge capital Q at the point P with the distance R. Okay, this R hat here we call it unit vector. Why we call it unit vector? Because the magnitude of the vector is equals 1. Okay, so the magnitude of R hat is equal. Is there any question? Any question? Any question? No? Okay. Okay, let us continue. So this is the formulation. If we take this capital Q, which is the source charge, outside the origin or beside the origin, for example, the vector position of the test of the source charge is R prime with the vector. Okay, this is blue one. And then the distance between the origin and a point P, we call it R, the vector, the position vector, okay. So this R prime here, we call it the source coordinate. And then this R vector is the field coordinates, okay. So this is the formulation, okay, this Q here. So the factor R minus R prime here, okay, the direction is outward, okay. Outward means you see that from this one, yeah. Basically, this basically is R minus R1, okay. The factor is outward. It means become far, far away, yeah, from capital Q, okay. So it means that if the Q is positive, greater than 0, so this the direction of the electric field on P is outward, okay. If the Q is negative, so the direction of the electric field at point P is inward. It means that the direction is to the capital Q, okay, to the source charge. Okay, is it understand? Are you understand? Okay. Any question? Any question? Okay. So in conclusion, we get that the direction of electric field of a positive a positive source charge. So the direction of the electric field is outward. Means that this is outward. Okay, so and the negative one, if the source charge is negative, so the electric field, the direction of electric field is inward. Okay, this is called outward and inward. Any question? Okay, so we see that from this formula, yeah, we have some remarks. Okay. If R to the 0, if R goes to 0, okay, this electric field also diverges. Okay. Diverges, okay, means that singular becomes singular, means it becomes singular. And also this F also becomes singular, okay, as R goes to 0. Okay. It means that around near the source charge, we have a very strong electric field. Okay? So we have very strong electric field. In other words, the Coulomb's law doesn't recognize the self-interaction, okay, in this case. So it's related to this singularity. It means that the Coulomb's law doesn't recognize the self-interaction. Okay. In quantum theory, if we quantize this case, it becomes, we could renormalize it. It means that we have a self-interaction. Okay, but classically, we do not recognize any self-interaction. Okay, classically. Okay, let us continue. Is there any question? So, what if there are two charges? Yeah. Yeah, this capital Q1 and capital Q2. Okay, and the distance between this origin, this is origin, Okay, this is Q1 is R1 prime, means the distance between O and Q2 is R2 prime, okay. And the field coordinate is R, R vector. Okay. So in this case, we could sum this electric field by Q1 and by Q2. Okay, we could sum. So it means that we have superposition of two charges. Okay, two electric field from two charges. Okay, so this is EQ1 is this one, and then from Q2 is the second term. The first term is from this is from this one and this one. Okay, so this is we call the superposition of electric field. Okay. Okay, is there any question about this one or not? Okay, if we continue, there are many charges, Q1, Q2 until Q capital N. Okay, you just sum this electric field A1 by cos by Q1 and E2, yeah, cos by Q2 and En cos by Qn. Just sum it to until En, okay, and then we could simplify the symbol, the sigma, this E1 plus E2 plus dots plus En is equal to, we can simplify this by sigma, yeah, sigma I1 to the capital N. EI, it means EI is the ith charge, yeah, the ith charge. Okay. Okay, if we replace this E1, EI is equal to K Q capital QI, yeah, over R minus R1, this modulus 2, 3, okay, times this, the difference between R and Ri, okay, the factor. So this is the discrete case, the first case, this discrete charges. So we have only a number of finite charges. Okay. So if so many particles, it means that this capital N goes to infinity. This summation above, okay, we could replace it by the integral. Okay, that's why this is for continuous charges. Okay. This is for continuous charges. Okay. So from discrete to continue, it means that we have approximation. Which one the approximation? The continuous one. Okay. This is approximation from here to here by taking N to the infinity, because there are so many charges. Okay. So for example, if you have 1 mole of electrons, for example, how many electrons for 1 mole? 1 mole electrons is 10 to the 23, 1 mole. is, I think, around 6. Okay. So there are so many. In this case. So we could, for example, if the form sphere, charge sphere, for example, charge cylinder, charge wire, a charge wire, and a charge disk, we could approximate it to the continuous case, okay? Because there is so many charges in that things, yeah, like sphere in that form, like spheres, wire, disk, or shell, for example. Yeah. Is there any question? Any question? Any question?
Excuse me, sir.
Yes.
Can you slide the screen a little bit to the left?
This one?
Okay. Yes. Thank you, sir.
Okay. I will give it upload in EduNext this whiteboard. Yeah. Maybe after Tuesday. Tomorrow we have a lecture also. So maybe after Tuesday or Wednesday. Okay. Any question? Oke, ini dari Anda bisa minta tolong apa namanya? Anda bisa ini nggak download file di EduNext yang saya sudah upload itu di modul 1. Saya pengen tahu bacaannya terlihat jelas nggak? Bisa minta tolong nggak? Kesaksian Anda saja lah, salah satunya.
Saya bisa baca, sir.
Bisa. Okay. Is it clear? I mean,
yes, I can
okay,
read.
good. Okay. Thank you. Okay, just a moment. Okay, good. Any question regarding this course? This material, course material about electric field? Okay, so this is the case. Let me see. Okay, we have already discussed, yeah, 3-body problem, yeah, 3 charges. Okay, 2 charges, I think is easy for you. So this is the example for electric field, yeah, for example. Oh, okay, this is for electric field. So we have 2 charges. Okay, we have 2 charges, capital Q1 and capital Q2. So this Q1 is positive, 2 column, and the others is -4 column. Okay. The position factor of Q1 is R1 prime is 0.4. Okay. And this Q2 is at 0.2, 0. Okay. As in the picture. So determine the electric field on 4.4 meter. Okay. Also, should be, there is a unit here. This is meter. Also, this is meter. Okay. So E1, we could say that this K, Q, capital Q1 over the magnitude of the difference between R minus R1 prime, okay, to the 3, okay, and then times the factor, the displacement, the factor difference between R minus R and R1 prime. Okay, K is around 9 times 10 to the 9. Okay, this is Q1, and this is the difference factor, the displacement, R minus R1 prime. Okay, it's okay. This is the factor here. Okay, and then for second charge, just a moment. Oh, okay, yeah. So the direction of E1 here is only the direction only in the x-axis, yeah, the direction of E1. Okay, the first electric field goes by this capital Q1. Okay, because this is 0. Okay, this one. Only this one is non-zero. Okay. Okay. Any question? Any question regarding this one? No. Okay. Okay. Okay, we have this E1. Oh, how about Q2? So Q2, we get this E2 is K Q2 over the magnitude of R, the factor, position factor R, the field coordinate R minus the source coordinates R2 prime, the factor, okay, to the 3, okay, and times the factor R minus R2 prime. Okay, so R minus R2 prime, like this, 4 minus 2 times I hat plus 4 minus 0, J, huruf J, saya lupa bahasa Inggrisnya. I and G, no, G is G. Yeah, okay lah. Yeah, G hat, okay. And this is the magnitude of the difference factor, yeah. This R minus R2 prime. Okay, so at the end we get that this E2 here, this is E2. We have minus, okay, because Q2 is minus. And this is the vector, okay, E2, like this. Okay, if we sum these two electric fields, E1 and E2, okay, we get that this E1 plus E2 is like this, okay. This is the E resultant or total electric field for these two charges, okay. So B, if we put a test charge, this one column test charge on B, we could determine the force on Q, yeah, okay. So the force on Q is Q times the electric field, yeah, the total electric field. Okay. So you just replace the units from Newton per coulomb times so by Newton, yeah, because we already multiply this the electric field, the resultant E total times Q. Okay. Is there any question related to this material, this example? No, there is no question. Okay. Okay, that's the discrete case. So we will consider for continuous charge. Okay. So in continuous case, we have three cases. Okay. One, this infinitesimal charge, yeah, D capital Q, whereas lambda dx, this lambda is the charge density per length. Okay, and there is also sigma. We call it also this charge density per unit area. Per unit area. Okay. Charge per unit. So this dense. Sorry, but this is not. So lambda is the charge density, but charge density, it means that the charge over length, okay? Sorry, I'm afraid you will misunderstand this one. So we call it charge density. It means that we have a charge per unit length, okay? So sigma is a charge density, is a charge per area. Okay, and finally, this rho here is a charge over a volume. Okay. So if the charge density is distributed all over the body, it means that the body is said to be uniform. Okay. So it means that uniform, the word uniform, it means the word uniform means that lambda, sigma, and rho are constants. Okay. So this is the case we will consider. For example, okay, we have uniform rod or wire, for example. Lambda is constant. It means that the charge is distributed uniformly, okay? And the width of the rods is omitted, yeah, because it's very small compared to the length of the rod. So it means that we can reduce this problem from two-dimensional becomes one-dimensional, okay, because we omit the width of the rod. Okay. So in this case, for example, we want to consider the electric field, the distance A. A is the distance between the right tip of the rod, yeah, to a point P, for example. Okay. So it means that this is P. Okay. So the length of the rod is L. Okay. This the left tip of the rod is at the origin. Okay. So this R prime here equal X, okay, because it's related to the source coordinates, okay. While the field coordinates we consider from the origin, yeah, is A plus capital L, okay. This capital L is the length of the rod. Okay, in this case, is there any comment or question? Any comment, a question? Comment and question? No. Any question? No. No. Okay. So because if you use the formula here, yeah. So it should be R minus R prime. Okay. It should be the same, yeah. R minus R prime here, because this to the 3, we have this only R minus R1, okay. So we could reduce it, R2 minus R1, the order becomes 2, okay. And then we get this one. So if we plug in R minus R1, okay, is A plus capital L minus X. Okay. So X here, yeah, is the this is the X here is the position of this infinitesimal charge. Okay. So because this is the position infinitesimal charge of the rod, is part of the rod, okay. So it should be the integral should be from 0 to capital L. Okay. This should be equal to okay. I should write it. This is equal to K lambda over minus 2 plus 1, okay, A plus capital L minus X minus 2, the minus, the order is minus 2 plus 1, okay. minus 2 plus 1. Okay. If we replace x by its boundary, this 0 and L, we will get that this finally the electric field at P is like this. Okay. So the Q, capital Q, okay. Basically, the charge of the rod is integral 0 to L lambda dx, because lambda is a constant, so we will get the Q total charge of the rod is lambda times L. So we could simplify the above formula. Okay, this should be lambda. Should be lambda times L, okay? This lambda L, capital L, is capital Q, okay, which is the source charge, okay, which is the charge of the rod, So basically, the electric field of the rod at point P is like this: K to the capital Q over A times A plus capital L. Is there any question about this example? Any question? Any question? No. Okay, just a moment, yeah. Okay, let's say the second example is a uniform ring. So ring, you know, ring. Okay, we have lambda constant. So the radius of the ring is capital R. Okay, and well, this is small part of the ring. Yeah, this dl. And the length of the L is, the formula is capital R times d theta. Okay. So the total charge of the ring is lambda times 2 pi R. Okay. Ya, itu adalah apa istilahnya? Keliling ya. Keliling. Okay, you could search in the Google for that English word. I forgot. Or circumference. Circumference, okay. Circular circumference, it means that the circular circumference, yeah, circumference. Okay. Okay, let us continue. So the formula of this electric field, oh yeah, we should first identify the source coordinate. Okay, the source coordinate is prime, r prime, is x prime I plus y prime j. Okay, g hat, I hat, and g hat. Okay, is equal to the r cos theta times I hat plus r capital R sin theta j hat. Okay, and the R here is the field coordinate is A. Okay, you can see from the figure, A times K hat. Okay, the difference between them, R minus R prime, is this one. Okay. So the magnitude of this R minus R prime is the square root of capital R squared plus A squared. Okay. Because the order is 3, you just times it 3 times, okay, we will get this 3 to the half, okay, 3 half, sorry, R squared plus A squared, yeah. And the order is 3 half, okay. So if we integral this electric field, so you will get this 0 to pi, okay, like this, okay. So because cos theta, d theta from 0 to pi, the integral of the cosine of theta is 0, yeah, in this case equals 0. Okay, and the other one also sinus theta, d theta from 0 to pi is also 0. Okay, this is one priority. Okay, so it means that the first term is 0 in this case. So we left with the last, or the third term, which is non-zero. And we will get this formula, okay? So this K hat is the direction of electric field, okay? So basically electric field in this case goes to Z axis, okay? Any question? Any question? Any question? No? Okay. Okay. So the third example, we have also been, but field is in y-axis, like this. This y-axis is perpendicular to this road. Okay, this is the distance between the center of the road. So this basically this A here. Okay. And also the fourth, if for example we have also a ring, we consider the electric field on y-axis. This point P on y-axis. So this is the homework. Yeah. We will collect it on Monday, on Friday. Yeah. Friday we will collect it in EduNext. Yeah. This two homework. Is there any question? Write down problem.
Sorry, sir, can you repeat?
Yes. Yeah. get the question? Hello? Hello? Is there any question? Question?
Sir, I'm sorry, sir.
Yes?
Your mic is really bad right now. We can't really hear you.
Yes. Cannot hear anything.
Cannot hear. Hello? What about this one? Hello? What about this one?
Your mic is still really bad, sir.
I see. Yes. Saya akan mengulangi apa namanya materi ini dari awal ya sebentar sebelum nanti saya absen. Jadi kita meninjau belum sekarang tentang medan listrik. Ya. Medan listrik ini didefinisikan itu dari hukum Coulomb. Ya. Oke, dari hukum Coulomb, ya. Jadi ada Q besar itu kita sebutnya adalah muatan sumber, yang Q kecil itu adalah muatan uji. Gitu ya. Jadi ini catatan memang kalau R-nya menuju ke 0 ini F ini menjadi tak berhingga. Jadi dengan kata lain kalau dia itu R-nya itu menuju tak berhingga, menuju 0, F menuju tak berhingga, ini kan artinya seperti muatan sumber dengan muatan apa istilahnya uji itu seperti bersatu lah gitu ya, seperti jadi nempel gitu ya. Jadi itu yang disebut namanya istilahnya interaksi diri gitu. Tapi di klasik itu kita tidak mengenal interaksi diri gitu ya. Jadi apa istilahnya self interaction itu tidak dikenal di klasik. Jadi ini istilahnya bisa dikatakan hukum Coulomb ini gagal lah ya untuk muatan titik, ya, point charge, gitu ya, ketika R-nya di titik itu, gitu. Jadi gagal ya. Nah, kemudian dari situ bisa kita definisikan muatan apa medan listrik, ya, yang kita sebut EP di sini di suatu titik P. Jadi biasanya ini ada definisinya, biasanya muatan ujinya itu kita ambil limit menuju 0. Jadi F-nya itu dibagi muatan uji ya, jadi didapatkan rumus yang seperti ini. Ini busur apa yang saya ini kelihatan ya, busur saya ini kelihatan. Yang saya tunjuk seperti ini kelihatan ya. Halo? Halo tes, terlihat nggak ini saya busur yang gerak ini?
Terlihat, Pak.
Lihat, Pak.
Oke. Oke, jadi dari situ kita dapatkan apa namanya tuh medan listrik ya. Q besar ini adalah yang terkait dengan muatan sumber dan R topi yang kita sebut namanya faktor unit atau ya faktor unit itu di mana besar itu adalah 1. Oke. Nah, jadi ini contohnya yang perumusan formal gitu ya dari medan listrik. Kalau saya tinjau suatu muatan sumber Q besar ya, dia vektor posisinya itu adalah R prime di sini, R prime vektor. Ya. Jadi terhadap titik asal atau origin itu vektor posisinya R prime. Sedangkan yang dari O ke suatu titik P itu kita sebut adalah R saja atau vektor R gitu. Nah, vektor R prime itu menandakan bahwa ini adalah koordinat sumber, sedangkan R yang tanpa prime saja itu disebut namanya koordinat medan, karena di sini memang nanti akan menunjukkan medannya gimana. Nah, jadi rumusannya itu seperti ini. Ya. Jadi EP sama dengan K itu konstanta, itu kali Q besar per besar R kurangi R prime pangkat 3 kali vektornya, selisih vektor. R vektor dikurangi R prime vektor. Oke. Nah, jadi ini lengkapnya. Jadi kalau di soal ditanyakan tentukan medan listrik, berarti ada besar dengan arahnya. Jadi Anda cukup menuliskan ini aja, sebenarnya udah cukup. Ini adalah kalau ditanya medan listrik. Nah sekarang kalau Q-nya itu positif, ini kan kalau Anda lihat di sini, arah P-nya, arah medan di titik P ini kan akan istilahnya keluar lah ya. Jadi searah dengan R dikurangi R prime. Yang kita sebut outward itu seperti itu, keluar. Sedangkan Q lebih kecil dari 0, dia inward, menuju ke Q, ya, menuju ke sumbernya. Jadi gampangnya itu seperti ini, ini yang positif, ini yang negatif. Kemudian medan listrik itu juga bisa kita jumlahkan. Kalau dia itu ada 2 muatan lebih, ya kita tinggal jumlahkan aja. Q1 itu akibat medan Q besar 1, disatukan Q besar 2. Oke. Jadi rumusnya seperti ini, dikatakan superposisi. Kalau dia itu ada banyak gimana? Ya ada banyak, tinggalin aja dijumlahkan. Kalau ada N buah partikel, ya berarti tinggal dijumlahkan. Nah ini biasanya disingkat jadi sigma I1 sampai N besar. Jadi seperti ini. Ya. Nah, dalam alam itu kita secara realitasnya itu yang ada itu adalah diskrit, oke? Nah, tapi ketika partikel diskritnya itu sangat-sangat banyak, gitu ya. Jadi tadi misalkan 1 molnya 10⁻23 kan, kalau dibandingkan dengan manusia kan 10⁻6, 10 berapa? Miliar itu 9 ya. Jadi masih sangat-sangat besar kan, masih sangat jauh gitu dibanding dengan jumlah manusia. Jadi kalau jumlah partikel sangat-sangat besar, maka sebenarnya kalau benda-benda seperti bola, meja, silinder gitu ya, atau yang lain yang Anda lihat gitu ya, itu sebenarnya bisa kita aproksimasi dengan aproksimasi benda kontinu namanya. Jadi benda kontinu itu adalah aproksimasi. Ya. Jadi dia dari sigma itu menjadi integral ketika M-nya itu menuju tabur hingga. Itu aja. Nah, jadi yang ini tadi saya kasih contoh, ini adalah medan listrik dari 2 muatan gitu ya. Kemudian yang ini medan kontinu itu ada 3 jenis lah ya. Ada yang rapat muatannya itu perpanjang, ya. Ada yang rapat muatannya per luas, ada yang per volume. Yang general itu yang per volume. Nah, jadi kalau untuk kasus ketika rapat muatannya itu terdistribusi secara merata ke dalam sebuah benda itu berarti lambda, sigma, dan rho itu dia konstan. Jadi dikatakan bahwa benda tersebut itu bersifat uniform. Ini contohnya ini adalah batang uniform itu di mana lebar dari batang tersebut itu jauh lebih kecil dibanding dengan panjangnya. Jadi itu bisa kita aproksimasikan dengan benda satu dimensi, jadi kita reduksi lah gitu. Jadi ini rumusannya, hasil integrasinya gitu. Seperti itu. Kemudian untuk cincin uniform ya. Ini biasanya DL di sini adalah kita sebut busur ya. Saya tadi lupa bahasa Inggris itu busurnya apa ya? Arc ya, arc ya. Arc of the circular. Oke. Arc. Oke, arc, ARC ya, arc. Oke, busur dari bagian busur lah yang kita sebut busur, arc. Jadi panjang busur ini adalah DL yang kali R kali D theta. Jadi nanti Q-nya gimana? Ya Q-nya tinggal DQ-nya itu tinggal lambda kali DL, di mana DL itu adalah R D theta. Theta dari mana? 0 sampai 2pi. Jadi muatan totalnya itu tinggal lambda kali 2pi R kali kelilingnya. Oke. Nah, ini jadi kalau R prime itu adalah dari O ke R prime ya di sini. Ini adalah X prime dengan Y prime. Posisinya ada I topi dengan J topi. Oke. Jadi dapatkan R besar itu adalah radius dari dari cincinnya gitu ya. Kemudian kalau koordinat medannya kalau Anda lihat di sini itu hanya sepanjang sumbu Z ya. Jadi A kali K di situ. Jadi kalau Anda langsung masukkan R dikurangi R prime, itu didapatkan seperti ini. Oke. Nah, jadi kalau Anda hitung besarnya, yang menarik itu R kurang R prime, besar itu adalah R kuadrat ditambah A kuadrat pangkat setengah. Karena di sini pangkat 3, tinggal Anda pangkatkan 3 aja, gitu. Jadi 3/2. Nah, jadi kalau Anda integrasikan secara total, E-nya, ya, jadi karena integral 0 sampai 2, pi cos theta d theta itu 0, dan juga sin theta, ya, maka nanti yang bertahan adalah suku yang ketiga, ya, seperti ini. Di mana E-nya jadi totalnya seperti ini. Dan K topi itu adalah arah dari medan listriknya. Nah, ini sebenarnya tambahan yang tadi saya belum jelaskan di di kuliah yang tadi yang bahasa Inggrisnya. Jadi kalau kita ambil A itu adalah jarak dari pusat ke suatu subunit. Jadi kalau A-nya itu sangat besar, jadi sangat jauh lebih besar dibanding radiusnya. Rumusan yang atas ini akan tereduksi jadi persamaan yang bawah ini. Ini artinya apa? Cincin kalau kita lihat dari dekat itu berupa cincin, tapi kalau kita lihat dari jauh itu berupa titik. Artinya apa? Cincin itu kalau kita lihat dari jauh itu bisa kita sederhanakan menjadi partikel titik. Jadi kan ini adalah rumusan partikel titik ya, Q per A kuadrat. Gitu. Seperti itu. Nah itu mungkin dari saya, kalau ada pertanyaan silakan. Karena terserah mau pakai bahasa Indonesia atau bahasa Inggris, bertanya silakan. Ada pertanyaan nggak? Oke. Kalau tidak ada, saya tinggal absen ya. Sekarang tanggal 24. Sekarang tanggal 24 kan ya? Betul ya?
Betul, Pak.
Sorry, ini belum di ini.